refraction of light. So far we have considered reflection of light phenomena, reflection of light on a plane mirror and also on spherical mirrors we have considered. Next in the line is refraction of light. In the geometrical optics, next is refraction of light. There are two kinds of boundaries are there. One is the plane boundary, other one is spherical boundary. Spherical boundary, convex as well as concave boundaries. Now, what is plane boundary? What is spherical boundary here? What is boundary? Boundary is separating two transparent media. Let us consider a medium 1, which is a transparent medium, and also another transparent medium 2, separated by plane surface. This two transparent media separated by plane surface. In that case, refraction is refraction of light at plane boundary. This is a plane surface separating two media. It's a boundary surface. In case if this surface is spherical in nature, we are going to consider refraction at a spherical boundary. Now, first we will consider the plane boundary refraction. Before we define what is meant by refraction of light, we will make some observation. Based on that we conclude. Let there be a plane boundary separating a transparent glass with air. There are two transparent media, glass and air, separated by a plane surface or plane boundary. There are two possibilities. Let a light ray traveling from glass enter into air at the boundary like this. In this case, angle of incidence is 0 degree because normal to the boundary. This is normal to the boundary. Normal incident ray is in the direction of normal. Angle of incidence is 0. Therefore, 90 degree angle it makes with the boundary. Therefore, it is called normal incidence. This ray is said to be incident normally. When the ray is incident normally, what happens? Since it is a transparent medium, it continues to go without any deviation. Ray continues to go. Will there be any changes light ray undergo? There is no change in the direction of light ray, but there is going to be magnitude of velocity of the light will be changed. That is, velocity in glass is Vg, velocity in air is Va, magnitudes are different. Velocity of light in air is 3 into 10 to the power of 8 meters per second, and velocity in glass is going to be less than this. So therefore, while entering the second medium, air medium from glass at the boundary, plane boundary, though normal instance there is no deviation, light ray undergoing change in magnitude of velocity. So in this case, the light is said to be undergoing a refraction. In second case, we consider same media, glass and air media. Now the light ray is incident at some angle theta I. This is what we call it as oblique incidence. Earlier case it is normal incidence. In this case it is oblique incidence. Ray is incident at an angle theta I with the normal here. In the case of oblique incidence, light ray travels from glass to air, and here there will be a change in the direction. Light ray will be undergoing a change in direction. In addition to that, speed of the light ray also, here in the glass it is Vg, here it is in air it is Va. There are two changes light ray undergoing. One is magnitude of velocity is changing and the direction of motion, direction of propagation also is changing. So therefore, here in this case, in oblique incidence, there is change in the magnitude of velocity as well as direction of velocity. So here also it is said to be undergoing refraction. So therefore, how to define a refraction of light? Whenever light ray traveling from one transparent medium to the other transparent medium, change in velocity may be in direction alone or in magnitude alone or both in direction and magnitude, that phenomena we call it as refraction of light. Refraction of light is change in velocity, phenomena in which change in velocity of light when traveling a transparent medium when entering into a transparent medium from another transparent medium, one medium to other transparent medium, is called a refraction of light. Change in velocity. Change in velocity. Velocity is a vector quantity, means it has both magnitude and direction. Velocity change is either change in magnitude or change in both magnitude and direction. Here, depending upon the ray in which how it is entering from one transparent medium to the other transparent medium. In the case of normal incidence, there is no change in direction, only change in magnitude. Therefore, it is called change in velocity here also. In the case of oblique incidence, there both magnitude and direction are changed. There also it is change in velocity. Change in velocity of light when entering one transparent medium from another transparent medium is called refraction of light. Here, what is change in velocity? Velocity is a vector quantity. Change can take place in magnitude or in direction or both. In the case of normal incidence, just now we have seen glass and air boundary. In the normal incidence case, there is no change in direction, only change in magnitude of velocity. Speed is changing. Therefore, refraction is change in velocity, even though there is no direction change. In the oblique incidence, there is change in magnitude as well as direction. So, in either of these two cases, change in velocity is taking place, light is said to be undergoing a refraction. Therefore, refraction of light is change in velocity when it is traveling from entering one transparent medium from another transparent medium is called refraction of light. Next one, laws of refraction. What are the laws of refraction? Incident ray, first law, incident ray, refracted ray, normal to the interface. Incident ray, refracted ray, and normal to the interface or boundary, normal to the boundary separating two transparent media lie in the same plane. Okay. Incident ray, refracted ray and normal to the boundary lie in the same plane. So, let us consider it's a boundary and let a ray incident here theta I. This is incident ray. Let ray undergo a refraction like this. This is theta or this is refracted ray. Whereas this is plane boundary. Now, normal to the boundary will be along this. This is normal. Normal to the boundary, incident ray. This is